Alright, here we are looking at angles of triangles. Our goal with this lesson is to be able to solve for missing angles using these relationships. So as we're talking about angles, we really have two types of angles in a triangle. Okay, we have interior angles. Those we're pretty familiar with, but we also get exterior angles. Exterior angles are created by extending sides of a polygon, in this case a triangle. Okay. And the angle that is a linear pair to our interior angle is our exterior angle. And don't worry, it doesn't matter which side you extend. Because of vertical angles, you'll get the same measure. So those are exterior and interior angles. Okay. In this unit, we're going to talk about classifying triangles and naming them. So when we're classifying, we classify triangles by sides, and we classify triangles by angles. Okay. So if they have three non-congruent sides, it's a scalene triangle. At least two, isosceles triangle, and all three being congruent, okay, equilateral triangle. For angles, if they are all acute angles, acute triangle. If we have one right angle, it's a right triangle. If we have an obtuse angle, obtuse triangle. And if all angles are congruent, it's an equal angular triangle. Okay. So here on page 127 in your student journal, we are going to classify these triangles by their sides and by their angle measures. So we measure these three sides. We're going to see that these three sides are all different. Okay, so we know that it's a scalene. And now also by the angle measures. Okay, notice that this is acute, but this, and they're different, but this one is obtuse. So we have an scalene obtuse triangle. Okay. Again, triangle ABC looks to have three different side lengths. Okay. But our angle C here looks to be right, so we have a right scalene triangle, or we can say a scalene right triangle. In 3, we have two sides that are congruent, so it's isosceles. And all angles, these end up being congruent, but this angle is different, but they're all acute. So 3 acute angles, so it's just isosceles acute triangle. Okay, on 4, when we're dealing with it on a coordinate plane, okay, and we want to classify ABC by its sides, we need to know its side lengths. So I went ahead and we are going to graph A. So A is 6, 6. B is 9, 3. And C is 2, 2. So in order to do this, we need to know things about its sides. We need to know their lengths. So we need to find those lengths. So using our distance formula, let's do AC first. AC, X parameters. Okay, 6 minus 2 is 4. 6 minus 2 again is 4. And I get 4 squared is 16. And get that twice, so I get square root of 16 plus 16, or the square root of 32. Now, the distance of AB. So AB, I do 9 minus 6 and I get 3. And I get 6 minus 3 and I get 3 again. 3 squared is 9, so I get 9 plus 9 under my radical. So then the answer is square root of 18. So that side I know is different than AC. Well, what about AB? I'm sorry, BC. So BC here. So if I do 9 minus 2, I get 7. And 3 minus 2, I get 1. 7 squared is 49, plus 1, square root of 50. Again, 3 different measures. So I know that this is scaling now. Okay. Now, determine if something is a right triangle. I need to know something about if there's a right angle. So if I look at my triangle, I have one that looks like an option. This angle is clearly acute, and so is this angle. But angle A here looks to potentially be a right angle. So remember that if we know if things are opposite, reciprocal slopes, okay, they're perpendicular lines, which means they have a right angle in them. Okay, so the slope, so M of line AC is equal to what? Okay, so rise over run, I go up 4 over 4. You can use the formula if you want, and I get 1 over 1, which is just a slope of 1. Makes sense because I go up 1 over 1, up 1 over 1. Okay, I'm also going to find the slope of AB here to see if that angle, if they're perpendicular. Okay, well, that slope is rise over run, so I'm going down 3 over 3. So I get a slope of -1 over 1, which is -1. These slopes are opposite reciprocals, so therefore it's a right angle. So this triangle we can classify as a scalene right triangle. So we also have our triangle sum theorem. We've probably been familiar with this before. It's just saying that our 3 interior angles, A, B, and C, add up to 180 degrees. The proof of this is quite unique. Okay, so if we go to a triangle on GeoGebra, okay, notice what we're utilizing here is that our alternate interior angles. So I just created a line that's parallel to BC through A. And because that line's parallel, okay, I can use my alternate interior angles. So 25.2 and this angle are alternate interior angles because AB is my transversal. Okay, and no matter how I move this, that is always true. My alternate interior angles are the same. Okay, I get that angle to be congruent to DAB. Same can be said for angle C, because angle C is congruent to EAC because of alternate interior angles, where AC is my transversal. And notice that those two angles end up being the same as well. Well, those two angles plus this angle are linear pairs. And by our angle addition postulate, these 3 angles add up to a linear pair, which is 180 degrees, which is also these 3 angles. So therefore, the angles inside our triangle must be 180 degrees. So the proof's there. Okay, we can see parallel postulate, angles 4, 2, and 5 are equal. We say alternate interior angles are congruent. We can therefore say they're equal in measure, and by substitution we can see that angles 1, 2, and 3 equal 180 degrees. Pretty important proof in geometry. Check that out in your book, page 234. Okay, the other theorems we're going to deal with is our exterior angle theorem. That states that if you have your exterior angle is equal to the sum of angles of your other 2 interior angles. Okay. Your other theorem that you're going to deal with is the corollary to our triangle sum theorem, that if we have a right triangle, means that's 90 degrees, then angle A and angle B have to add up to 90 degrees. And that's a corollary. It's just as simple, another theorem that can be proven easily. And because we know a triangle sum is 180 degrees, and a right triangle has a 90-degree angle, if we subtract that from there, we know the other two angles have to be 90 degrees. If you want a more formal proof, go ahead and check out page 237 in your book. Okay, so how are we going to apply these in our problem sets and in this class? Okay, so angle 1 is our exterior angle. So that means that 53 plus the other interior angle is equal to the measure of angle 1. So this adds up to 106. That equals the measure of angle 1. Okay. 8x minus 5 is an exterior angle. 5x plus 15 is that interior angle, and 40 is that interior angle. So if I want to solve here, I know that 40, the two interior angles, plus the exterior angle, sorry, not plus, will equal my exterior angle. Collecting like terms, I get 5x plus 55 equals 8x minus 5. So I want, at this point, I got x's and constants on both sides, so I'm going to pick what side I want where, and I like positive x's. So I'm going to subtract 5x here, subtract 5x there. So then I want the numbers on the other side, so I'm going to add 5 here, add 5 here. So as I simplify this out, I get 3x, that goes away, 60 here. Dividing by 3 on both sides, I get 20 is equal to x. So now to find my exterior angle, I have to do a substitution. And 8 times 20 minus 5 is 160 minus 5, which is 155 degrees. Obtuse angle, that makes sense. I got an obtuse angle there. That concludes our notes for tonight. Please bring any questions you have to our next class.